Good evening, folks. Tomb Raider 582 is back in the multiverse, and I'm in the planetarium. Let's check out some things here. Dion on a backdrop of Saturn. Aurora seen from space. Wow, that's a keeper. I love the northern lights. Quite a sight. Let's see.
The Space Shuttle Discovery has flown to space more times, and has carried more crew members to orbit, than any other craft, making it a truly amazing achievement. Clocking up 38 trips to space and back, and spending 352 days in orbit, Discovery has circled Earth 5,628 times, and has traveled almost 143 million miles.
We'll be heading to the sun soon. Moon crater. Neptune's great dark spot. Oh, I don't know what this one is. Let's see. 50 rooms in the planetarium alone? Wow. Hmm. Yes, I got a rocket into orbit. Slice puzzle, yes. How we are going to the moon video? No. Where is that? How are we going to the moon video? Let's see.
There's a lot to do in the Multiverse Planetarium. Some of it is out of this world. For example, the Moon View Room lets you play with toys, in a mostly zero-gravity environment. Head over there, and play a bit of zero-G catch. Rockets can be fired into orbit around moons, planets, and asteroids. You've just got to get the aim right. Why not challenge your friends to see how many rockets you can get into orbit around Earth? Some rooms contain planetary slice puzzles. Your job is to slot the slices back into the planet in the correct orientation. Doing this will reward you with a tasty tidbit of knowledge. Go on. Like all the king's horses, and all the king's men, go put all the planets back together again. There are various videos to watch throughout the app. The Cassini Room and the Moon Room have my two favorites. But you can find many more across the planetarium. That is, if you bother to hunt for them.
Cassini room and the moon room. Okay. Cassini and moon room. Curiosity at the hot and drill site on Mars. Huh. There's talk about Elon Musk trying to colonize the moon. It's another option because Mars is quite far away. Ooh, SpaceX.
The SpaceX Dragon made its maiden flight in December 2010, becoming the first commercially built and operated spacecraft to be recovered successfully from orbit. It can carry up to 7 passengers, and was the first private spacecraft to take humans to the International Space Station. Standing just over 8 meters tall, the Dragon and its successors launch atop a Falcon 9 rocket, and return to Earth via an ocean splashdown, thanks to a set of parachutes. The Dragon series operates as a cargo shuttle, for taking equipment and other items to and from the ISS.
Jupiter is even further away. It will take about 5 years to reach it. Okay. Ooh. Let me see. And this one, I know what I'm gonna do. No! Whoa! Whoa, 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 whoa. It's going around. Will he come this way? No. Let's check out the sun. But I also want to see the moon.
The Sun lies at the heart of the solar system, where it is by far the largest object. It holds 99.8% of the solar system's mass, and about 1 million Earths could fit inside the Sun. The visible part of the Sun is about 5,500 degrees Celsius, while temperatures in the core reach more than 15 million degrees. You would need to explode 100 billion tons of dynamite every second, to match the energy produced by the Sun. The Sun is one of more than 100 billion stars in the Milky Way. It orbits some 25,000 light-years from the center of the galaxy, completing a revolution once every 240 million years. Explore the rest of this room, to discover more about this amazing giver of life and light. This image shows cells of boiling plasma on the surface of the Sun, each about the size of Texas. But, what causes this strange pattern? At the core of the Sun, gravity produces immense pressure and heat, compressing hydrogen into helium, by a process called nuclear fusion. Nuclear fusion generates energy. Particles of light called photons carry this energy up through the layers of the Sun, taking about 170,000 years to get from the core to the top. Speak greater than. At the surface, hot plasmas rise and fall, like the ooze in a lava lamp, which transfers energy to the Sun's surface, where the light finally escapes into space. This erupting prominence occurred in 1992, and rose to 365,000 miles above the Sun. Space weather like this can damage satellites, corrode pipelines and affect power grids. Approximately every 11 years, the Sun enters a new solar cycle, and its geographic poles reverse their magnetic polarity. When this happens, the Sun's atmosphere changes, from quiet and calm, to violently active. This phase is known as the solar maximum, and it is a time of numerous solar storms, sunspots, solar flares, and
Mm.
coronal mass ejections.
Oh,
Why not
no.
check out our space weather room for more about these incredible displays of solar power?
Comet.
Early astronomers noted that the tails of comets always point away from the sun, and they wondered if there was some kind of wind that flowed outwards from the star. They were right, and what they were witnessing was the effect of the solar wind. The solar wind is composed of plasma, an electrically conductive substance that represents the fourth state of matter, after solid, liquid and gas.
Mm.
This constant stream of plasma blasts planets across the solar system with particles and radiation, which can stream all the way to the surface of a planet, unless thwarted by an atmosphere or magnetic field. The connection and interactions between the Sun, solar wind and Earth are what drive the seasons, ocean currents, weather and climate on our planet. The Sun is located in a galaxy called the Milky Way, which probably looks like this one. The Milky Way is a spiral galaxy, with 2 major arms, 2 minor arms, and several spurs. Our solar system is located on the inner edge of the Orion spur, that extends outwards from the minor Sagittarius arm. From this location, the Sun orbits around the center of the galaxy, bringing the planets, asteroids, comets and other objects along with it, including you and me. The Sun itself is orbited by 8 planets, at least 5 dwarf planets, tens of thousands of asteroids, and up to 3 trillion comets and icy bodies, as well as numerous artificial objects, including a Tesla.
Including a Tesla. That's right. Oh, boy. Oh, Stonehenge Cinema. I see this.
Many ancient cultures believed that the Earth was the center of the universe, and the Sun revolved around the Earth. This image from an old star atlas illustrates this theory, which was known as geocentrism. It puts Earth in the center, orbited by the Sun and all the other planets. It wasn't until 1543 that Nicolaus Copernicus suggested a new theory, called heliocentrism, where the Sun is the center of our solar system. In 1610, Galileo Galilei's discovery of Jupiter's moons confirmed that not all heavenly bodies circled the Earth. However, the Catholic Church thought his work was so heretical that they warned him to abandon it.
Mm. Massive sunspot.
The Sun is not a solid body, so different parts of the Sun rotate at different rates. By tracking sunspots, like this one seen by SOHO in 2003, we know that, at its equator, the Sun spins around once about every 25 days, but at its poles, the Sun rotates once on its axis only every 36 days. The solar system as a whole is moving with an average velocity of 450,000 miles per hour. But even at this speed, it takes us about 240 million years to make one complete orbit around the Milky Way.
Let's check this out.
Launched in 2018, the Parker Solar Probe is revolutionizing our understanding of the Sun, where changing conditions can affect not only Earth, but the entire solar system. Parker travels closer to the surface than any spacecraft before it, facing brutal heat and radiation, to provide the closest ever observations of a star. The probe is using Venus's gravity to gradually bring its orbit closer to the Sun, and will eventually fly through the Sun's atmosphere, as close as 3.8 million miles from the surface, well within the orbit of Mercury, and more than 7 times closer than any spacecraft has come before. At closest approach to the Sun, the front of Parker's solar shield faces temperatures approaching 1,377 degrees Celsius. However, thanks to the 4.5-inch thick carbon composite shield, the spacecraft's payload will only be about room temperature.
Okay.
On June 5, 2012, the Solar Dynamics Observatory photographed the rarest predictable solar event, the transit of Venus across the face of the Sun. This event occurs in pairs, 8 years apart, which are separated from each other by either 105 or 121 years. The next transit will not happen until 2117. The Solar Dynamics Observatory is a NASA spacecraft that launched in 2010, in time to observe sunspot and solar activity as they reached their peak. The satellite continuously records high-definition views of the Sun's atmosphere in unprecedented detail. So far, SDO has captured high-resolution views of solar flares, provided more information on predicting magnetic activity, and even captured the solar transits of Venus and Mercury.
Okay. Stereo.
The twin stereo spacecraft were launched in October 2006 to study the structure and evolution of solar storms as they emerge from the Sun. The two spacecraft, one ahead of Earth in its orbit and the other trailing behind, provided the first 3D images of the Sun, and collected data on many types of space weather, especially coronal mass ejections. In July 2012, the Sun fired off the most powerful CME seen in 150 years, whose charged particles barely missed Earth. Instead, the CME struck Stereo A, which was built to ride out such storms and record a wealth of data. Although Stereo B has been out of contact since September 23, 2016, Stereo A continues to make discoveries about the Sun. NASA first sent an orbiting observatory to the Sun in 1962, which has since been followed by several successful missions from Europe, Russia, and Japan, with India scheduled to join them in 2022. The Sun is the only star we can study up close. The more we know about it, the more we can learn about other stars in the universe, and understand how life developed on Earth. Spacecraft also study the solar wind, which dominates the space environment throughout the solar system. As we send spacecraft and astronauts further and further from home, we must understand this space environment, in order to keep them safe.
Oh, look at that. Earth versus Sun by
Our home
size.
star is a yellow dwarf, although it's not exactly yellow, and not exactly small. In fact, the Sun burns a bright white, although on Earth it may appear different colors, because our planet's atmosphere scatters some of the light. As for its size, if the Sun was shrunk to the size of a basketball, Earth would only be as big as a sesame seed. That said, even with a radius of 432,168.6 miles, our Sun is not an especially large star, compared to others in the galaxy. The Sun is 93 million miles from Earth, and this distance is called an astronomical unit.
No sunlight.
Light from the sun takes about 8 minutes to reach us here on Earth, but about 5.5 hours to get to Pluto. The surface of the sun is hot enough to make diamonds not just melt, but boil.
Ooh.
However, it's nowhere near as hot as the blazing core, where temperatures reach a whopping 15 million degrees Celsius. One of the most impressive and visible solar events observable from Earth is a solar eclipse, which happens when the moon crosses between our planet and the sun. An eclipse can be total, annular, or partial, as captured in this image taken by Europe's Proba 2 satellite. By a coincidence of nature, the moon is about 400 times smaller than the sun, but the sun is about 400 times further from the Earth. So, simple geometry dictates that the apparent disk of the moon is almost exactly the same size as the apparent disk of the sun. There will be a total solar eclipse in December 2021 and April 2023, but they will not be visible from all parts of Earth.
The planetarium entrance lobby. What lies beneath? Hey, what is that up there? See this? Yeah.
This image was taken by the ESA's solar orbiter on the 28th of May 2020, and shows an area approximately 125,000 miles square in the middle of the sun. It shows the sun's granulation pattern that results from the movement of hot plasma in the convection zone under the sun's visible surface.
Wow.
The sun is not just a big bright ball. It has a complicated and changing magnetic field, which forms things like sunspots and active regions. The magnetic field sometimes changes explosively, spitting out clouds of plasma and energetic particles into space, and sometimes even towards Earth. This full disk image shows a map of magnetic properties for the whole sun, taken by ESA's solar orbiter on the 18th of June 2020, with a large magnetically active region in the lower right-hand quadrant.
Whoa, check that out.
This image shows the solar surface in a particular ultraviolet wavelength produced by hydrogen, the most abundant chemical element in the universe. When scientists first began to study the sun, helium had not yet been discovered, so they did not understand some of the chemical patterns they saw on the surface. In 1868, a man named Norman Lockyer thought that these patterns could have been created by a brand new element. He decided to call it helium, after the Greek sun god Helios. 25 years later, helium was discovered on Earth.
Chemical composition.
The sun, like other stars, is a gigantic ball of gas. Nearly 3/4 of it is hydrogen. The rest is mostly helium, followed by oxygen, carbon, neon, nitrogen, magnesium, iron and silicon.
Corona seen by the Solar Dynamics Observatory.
The corona is the outermost part of the sun's atmosphere. It is usually hidden by the bright light of the sun's surface, but can be seen easily during a total solar eclipse. Even though the corona is the outer layer of the sun's atmosphere, and therefore furthest from its core, it is hundreds of times hotter than the deeper surface, and no one really knows why. The average temperature of the corona is about 1 million degrees Celsius. This composite image of the sun reveals the entire solar atmosphere in multiple wavelengths. Each color represents a different wavelength of extreme ultraviolet light, present in the sun's corona. The
Mm,
wavelengths in turn correlate to material of different temperatures, resulting sometimes in completely different views of the same sun.
okay. So I'm gonna stop the video here, and my next video will be on the moon. Inside Luna, the moon. All right, folks. See you in a bit.